Hello, Princeton Tigers. All right, so today in the back, we're going to be reviewing our exponent rules. So for our first problem, we have x squared times x to the fifth. I know there's some rule that I can use for when I multiply exponents with the same base, but I don't remember it. So instead, I'm just going to expand it. So I'm going to have my x times x. I'm trying to simplify this. So I have two x's for the x squared, and then I have five x's for my x to the fifth. Now I want to see how many x's I have in total. So I'll count. 1, 2, 3, 4, 5, 6, 7. So if I simplify, I have 7 x's, so what will my exponent be? Yeah, I have x to the 7th power. All right, now I'm going to look at this. So I started out with x squared times x to the fifth, and then I ended up with x to the 7th. How did I get that? Right, you can also just add your exponents, because 2 plus 5 gets you to 7. So if you have the same base and you're multiplying, add your exponents. All right, in the second problem, I have 6 to the 8th times 2 to the 7th times 6 cubed. I just made up a rule for multiplying exponents where it's same base and multiplying equals adding exponent. All right, but in this one, these two numbers don't have the same base. So I need to figure out what I can do. And I continue looking at the problem and I see, okay, I have two terms right here that do have the same base. So I can that tells me I have 8 sixes and 11 sixes. So how many sixes do I have altogether? Or 8 sixes and 3 sixes, I just gave away the answer. You have 11 sixes altogether. And then I can't combine my 6's with my 2's because those are different bases. So I can just multiply 6 to the 11th times 2 to the 7th. All right, now looking at problem number 3, I have 3 7th over 3 squared. This fraction bar tells me we're doing what? Yeah, we are dividing. So I have my rule for same bases and multiplying. What do I do for dividing? So if I have the same base and I'm dividing, I just don't remember from last week. And we don't know what this is yet. So let's figure this out. So I'm going to expand it. So I'll have 3 7s on top. And then I'll have 7 3's on top and 2 3's on the bottom. This fraction bar means what? Division. And so I have 3 up top, 3 down here. 3 divided by 3 is 1. Multiplying by 1 gives you the same answer, so we can cross it out. I have 2 more 3's we can cross out. We are left with 1, 2, 3, 4, 5 3's. Are they in our numerator or our denominator? Yep, they're in our numerator, so we can write this as 3 to the 4th over 1, which is just, 3 to the 5th over 1, which is just 3 to the 5th. All right, so now I'm going to look at these numbers and try and figure out my rule for dividing. So we had 7 3's up top, then we could take away 2 because there were 2 at the bottom, and we were left with 5. So what operation were we doing? Yeah, we were subtracting. So if you have the same base and you are dividing, you subtract the exponents. So let's try this on one more. This one's a little bit trickier. So I have x to the 4th times x cubed over x squared. So we have the same base in all of our terms, but we're doing two operations, multiplying and dividing. So what do I do first? First, I'm just going to look at the numerator. All right, so here I have the same base, and I have multiplying. I remember that I do what? Yeah, I add my exponents 3 plus 4 is 7. In my denominator, I'll just rewrite x squared. X squared is the same as what? Yep, x to the second power. All right, so now I have x to the 7th over x squared. Now I'm dividing, so I can use my rule up top. If we have the same base, yep, we have the same base. This fraction bar means what? Means division. So I can subtract my exponents and get x to the 5th. Go ahead and try the rest of the problems on your own. Good luck.